Do isomers of butene? That is the question. Bute means how many carbons are there? What is the general formula? What is the general formula? CnH2n. You check. Okay, now. So isomers of butene was the question. What you cannot see clearly, right? Okay. So first of all, you should know the formula of butene. What is the general formula? CnH2n. So bute means how many carbon? 4 carbon. H2n means H8. C4H8. That will be the general formula for butene. That's the formula for butene. First of all, you draw the basic structure. How many carbon? 4 carbon with one of them double bond. Okay. So 1, 2, 3, 4. Double bond can be on the first carbon. That is one structure. Okay. Now the double bond can be on the where second carbon, second structure. Okay. Now, is there any other possibilities? Hmm? What? Three carbon. Here you are saying the bond. Double bond. I'm asking. That's fine. Huh? There'll be two. Two isomers. Draw these two isomers. All of you draw. Okay. Now you can draw this one as well as there is a double bond here, then there is a single bond, then there is a single bond. If you see a structure like this is the same thing. Okay, here you have a carbon, here you have a carbon, here you have another carbon, here you have another carbon. This means this is a butene. If in the question paper they are showing like this is how to read it. Okay, now this one, how will you draw? There is a single bond, then there is a double bond, again single bond. One carbon, two carbon, three carbon, four carbon. So each end there will be one carbon. Okay, so check, is there any other structure possible? That's it. That's it. That's it, right? Okay. Clear. If some of the butene is okay, you understood the structure as well. Okay. Now try to do isomers of okay. Do the naming also. Do the naming also. What is this? This is butene itself. Basic butene. Then what about this one? 1, 2, 3, 4. The second carbon is the double bond. So you will name it as but 2 That is the naming. Understood? Okay. Got it, right? Okay. Now you tell me. This is okay? Okay. So what's the atomic number of carbon? What's the atomic number of carbon? What is the atomic number of carbon? Yes, Raya. 6. Electronic configuration? 2, 2, 4. Which bond is present in carbon? Covalent bond. In which form carbon is present in the atmosphere to the maximum? In which form? Carbon dioxide. And what's the percentage of carbon dioxide in atmosphere? 0.0. What is the percentage? 0.0. Check the textbook, first page, it is there. What is the percentage of carbon dioxide in the atmosphere? 0.03. 0.03% of carbon dioxide. Now, why carbon cannot form ionic bond? What is covalent bond? Bond formed by sharing of electrons. Why carbon cannot form ionic bond?
Because it has valency 4, which means it's just as easy to remove electrons as it is to add electrons. So
What? It is easy to remove and add electrons.
It's very hard to remove all the electrons and to add.
That point is not valid. You have to write 2 sentences as read that. These 2 points, yeah.
You gain 4 electrons forming C4 minus ion, but it would be difficult for the nucleus with six protons.
Yeah, it is difficult to gain 4 more electrons and to become C4 minus. Why? Because it is difficult for the carbon with
Difficult for the nucleus.
difficult for the nucleus to hold 6 protons. Already how many protons are there?
6 protons to hold 10 electrons.
Yeah. So it will be difficult for 6 protons to hold total 10 electrons. Normally 6 electrons and 6 protons are there for carbon. Okay. So if 4 more is coming, it is difficult for 6 protons of carbon to hold 10 electrons. And in order to remove 4 electrons, high amount of energy is required. So gaining and losing is not possible. Okay. Now do the electron dot structure of ammonia. Electron dot structure of ammonia. See, how will you know what they are asking? Whether the compound being asked is forming ionic bond or covalent bond? How will you recognize? How will you recognize? If it is a metal and a non-metal, it is always ionic bond. Ammonia means nitrogen and hydrogen. Hydrogen, if it is coming in the compound, it is not a metal, not a non-metal. So with the hydrogen, go for and just check what is along with the hydrogen, NH3, ammonia. So nitrogen, it will be covalent bond. So if any hydrogen compound is coming, you have to check. Okay, it could be covalent. Always ionic will be between metal and non-metal. Clearly, if it is a metal and a non-metal is there, then only it will be ionic compound. Okay, so do the formation of ammonia and hydrochloric acid, HCl. Formation of ammonia means electron dot structure of ammonia is what they are asking. So whatever be that, you have to write the electrons of nitrogen as well as the electronic configuration of nitrogen and hydrogen. That is the first step. First of all, you should write the formula. What's the formula of ammonia, Ryan? Ammonia formula, what is it, Surya? NH? Yeah, ammonia formula is NH3. Then you should write the electronic configuration. Nitrogen, what is the electronic configuration? 2, 5. 7 is the atomic number. So 2, 5. And hydrogen, it is what? 1. Okay. So when you draw nitrogen, the 5 electrons of nitrogen should be shown. When you draw the circle, all these 8 electrons should go inside the circle. Now what happens? Got it wrong? You did what way? What did I just say? That is the main mistake you all will make. Instead of covalent, you will try doing giving electrons, ionic bond. Completely wrong. Okay. Main mistake you all will make. Ionic bond, it will be very clear that there will be a metal and a non-metal. No doubt in that. Calcium, sodium, potassium, any metal will be there. Metal and a non-metal means then only ionic bond. Okay, always if hydrogen is there, check it again. Okay, ammonia you finished. Hydrochloric acid. After ammonia, you try hydrochloric acid. After ammonia, try doing hydrochloric acid. HCl. Yes, HCl it is. One. Chlorine it is 2, 8, 7, right? Chlorine is 2, 8, 7. So chlorine it will have how many electrons to be shared? Only one electron. Seven electrons of chlorine, 1 electron of hydrogen. This will be HCl, or you can write it as. Okay. Done. Okay. Now, what's this one? Allotropes. What do you mean by allotrope? What do you mean by allotrope? What do you mean by allotrope?
Like different structures, different structures.
Different structural formula, but
Same chemical.
same chemical formula. Okay, different structural formula, but same chemical formula. Okay, yeah.
Same chemical formula? Oh, yeah.
Yeah. Different structural formula, same chemical formula. Is it allotrope? That is allotrope. Then what is isomer? Isomers are having, hello, those who are attending online, are you all sleeping? I think you all are sleeping. Aaron, Alvin. Ah. Okay. So what is isomer? Isomer is having the same chemical formula but different structural formula. That's an isomer. What about allotropes? I asked allotrope. Allotropes are different forms of different
Physical structures of the cell.
different forms of carbon. Carbon exists as graphite, carbon exists as diamond. It is the way in which the carbon atoms are arranged. Based on that, different forms of carbon is present. That is basically the allotropes of carbon. Okay, what is given in the textbook? Read.
Carbon only, generally seeing the definition. What is it? Like different forms of.
Different forms of an element. What is given? Ryan, read.
The element carbon occurs in different forms in nature with widely varying physical properties.
Yeah, it is a different forms of an element with varying physical properties. Chemical property will remain the same because content is carbon itself, but varying physical properties. Why different physical properties? Because of difference in the arrangement of arrangement of atoms. Generally, if you say the physical properties is different and it depends on the arrangement of atoms. Example, diamond, graphite. Why graphite is slippery in nature? It is there in the textbook. Check why graphite. You don't have that. Why graphite is slippery in nature?
Its structure is formed by excellent
Why graphite is slippery in nature? The two different structures result in diamond and graphite having very different physical properties, though their chemical properties are same. Diamond is the hardest non-substance and graphite is smooth and slippery. Because the graphite structure is formed by hexagonal arrays by placing one layer above the other. Okay, and graphite is also a good conductor of electricity. So, if anything they are asking why graphite is like that, you have to explain the structure of graphite. In graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, giving hexagonal array, and one of the bond is double bond. Okay, and hence the valency of graphite is, so the carbon is satisfied, and graphite structure is formed by placing the hexagonal arrays one above the other. That is how graphite is formed. Okay. And due to this structure, the graphite is smooth and slippery. And why diamond is a harder substance? Because in diamond, each carbon atom is bonded to 4 other carbon atoms in a rigid 3-dimensional structure. That makes that makes diamond the harder substance now. Okay, then fullerene, how is it present? Buckminster fullerene. Is the 60 carbon atoms is arranged in the shape of a football. Now, what's the reason for versatile nature of carbon? What do you mean by versatile nature? What do you mean by versatile nature?
Wide combination.
The ability of carbon to form a wide number of compounds. That is versatile nature of carbon. It is due to 2 phenomena, tetravalency and catenation. What do you mean by catenation? The self-linking property. Each carbon atom can form long chains, branched chain or cyclic chain with many number of carbon atoms by carbon-carbon bond. That is self-linking property. And another reason is tetravalency. Carbon being valency 4, it can form bond with 4 other carbon atoms or 4 other atoms. Okay. Now another question. Silicon is also tetravalent, but silicon is not versatile in nature. Why? No, silicon is also showing tetravalency, but
Oh, because it's too heavy.
but it is not showing the properties as shown by carbon. What is the reason?
The maximum silicon can show like bond is 7 to 8, right?
Why? What is the reason? Carbon is the smallest element with valency 4. So the shared electrons is closer to the nucleus, so there will be strong force of attraction towards the nucleus. Whereas silicon, the 4 shared electrons is in the next shell. For carbon, only 2 shells are there, K shell and L shell. The shared electrons are in the L shell, there will be strong force of attraction towards the nucleus. Carbon being smaller in size, there will be strong force of attraction towards the nucleus. Whereas if you take any other element with valency 4, the electrons will be in the next M shell or N shell like that. So the force of attraction towards the nucleus will be less. Okay, so it cannot form, it will not show versatile nature. One reason for formation of strong bonds by carbon is its a small size. That is the answer. Carbon is the smallest element with the valency 4. That is the reason. Okay. Now saturated compounds, single bond, all alkanes. What's the general formula of alkane, Ryan? C2, general formula. CnH2. Then what?
And
What?
I don't know.
The general formula of CnH2n plus 2 alkane. Alkene CnH2n. Alkyne CnH2n minus 2. These are the general formulas. Okay. Now, so in cyclocompounds, you have to study pentane, hexane, and cyclopentane, cyclohexane, and benzene only. Okay, draw the structures of cyclopentane, cyclohexane, and benzene. Draw. All of you draw the structures of cyclopentane, cyclohexane, benzene. Draw the structures. Finish doing? Cyclopentane. 5 carbon. 1, 2, 3, 4, 5. In the shape of a pentagon. Now, each carbon 2 valencies are already satisfied. You need to add 2 more hydrogen only. Okay, so it will be. Yes, Darsh. This will be cyclopentane. Now, cyclohexane. Cyclohexane. Okay. Finish. Now, benzene. So, benzene also, how many carbon? 6 carbons with alternate double bond. That is the difference between hexane and benzene. This is benzene. Okay, all that is okay for everyone, right? Now, what? So that is okay. Now, what are heteroatoms? What are heteroatoms?
Elements that are replaced.
Elements.
Heteroatoms.
Elements. Yeah, correct.
Replace hydrogen.
Atoms or group of atoms which replace hydrogen in a hydrocarbon. See, that is a heteroatom. It is there in the textbook. See over here. Over here you have. In such compounds, the element replacing hydrogen. It's an element, okay, not compound, not right, okay. The element which replacing hydrogen in a hydrocarbon is known as heteroatom. Okay. The elements replacing hydrogen in a hydrocarbon is referred to as heteroatom. Now, what are functional group? What are functional group? What are functional group? Do you finish studying and all the chapters? Already all of you finished writing the pre-board one. Waiting for pre-board 2, eagerly waiting for board exam on February 21st. What is functional group? Stuff. Oh, your answer will start with stuff. Very good.
Group of heteroatoms change the properties of
The heteroatoms and the group containing confer specific properties to the compound, regardless of the length and nature of carbon chain. So, heteroatoms, a group of atoms, or what you can say? Atoms or group of atoms, you can say. Okay, atoms or group of atoms present in a hydrocarbon chain, which determines what? Which determines the property of that hydrocarbon. Okay, normally if it is CnH2n plus 2, then it is an alkane. Okay, if one of the alkane is replaced by Cl, one of the hydrogen is replaced by with the chlorine, it becomes chloroalkane. So if it is, for example, 1 minute, okay. See. What compound is this? What compound is this?
Cycle.
Cyclopentane. Without carbon, as I told you. Each end you will put carbon. That is a compound. This is what? Cyclohexane. Yeah. This is cyclohexane. Now what about this? This is benzene. Okay, this representation is also correct. Now I'm talking about functional group, atoms or group of atoms which replace hydrogen in a hydrocarbon chain and which determines the properties of that hydrocarbon. We call it as a functional group. Okay, now C3H8. This is actually an alkane. Propane. This is propane. What about this? What about this? Chloropropane. Chloropropane. Okay, draw the isomers of this. So here one of the hydrogen is replaced with the chlorine. One hydrogen is replaced with chlorine. One hydrogen is replaced with chlorine. Don't close. One hydrogen is replaced with the chlorine. Okay, so this will be chloropropane. Now my question is draw isomers of C3H7Cl. Do first. Draw isomers of C3H7Cl. Finish. Finish. So, isomers of this one, right? First isomer, one of them is chlorine. Rest all will be hydrogen, okay? I need not mark hydrogen, right? 1, 2, 3, 4, 5, 6, 7. Next will be correct? Then is there anything else possible? No, only these two possible, right? And what is the name of the first one? This is chloropropane. What about the second one?
Chloropropane.
2-chloropropane. That for double bond and triple bond, you will put like prop 2 in, prop 3 in like this. Okay, so here, this is actually what, a branch, right? Or you can say this is, yeah. For this one, you will put where you have that chlorine, right? So 2 chloropropane. Okay. 2 chloropropane. Propane. Okay. Now I have a question. This is done. What is the maximum number of electrons that no. What is the maximum number of electrons that can be accommodated in a K shell? K
Okay.
shell is 2. L. K, the maximum number of electrons is 2. L.
8.
M.
Um,
Hmm?
6 plus 2.
N. Maximum number of electrons that can be accommodated in which formula? 2n square formula. 2 into 1 square. 2 into 2 square. 2 into 3 square. 18. 2 into 4 square. 32. This is how it works. Okay. Now, which element is atomic number 19?
Nitrogen. No, potassium.
Argon.
19. 19.
Argon.
What?
Argon.
Argon is 19? 18 is argon.
Potassium.
Potassium, right? Correct? Right? Potassium. Write the electronic configuration of potassium. This is not there, I know, but this can be asked. You have metals and non-metals.
Ma'am,
Yes.
can you tell me how to name the isomers?
Name isomers. Isomers of what?
No, like gently, how do you name them?
Generally, there is nothing. There is no general thing. Only by practice you will get.
No.
There is no general rule is not there. You send me any particular question, I will tell you how to answer.
Chloropropane. Ma'am, the last one you read, chloropropane.
So chloropropane, propane.
Yes, ma'am.
So in the first case, it is the normal propane itself, because in the first carbon itself was a functional group. In the second question, the second carbon was a functional group. You have to name the carbon in which has a branch. That's he's teaching you something, then you turn and sit. So in the second question, in the second carbon was the functional group. So you would put 2, and what is the functional group? Chloro, and what is the compound? Propane.
Okay, ma'am.
Okay.
Okay.
Now, what did I ask? Electronic configuration of potassium. Did you all write? Okay, tell me. Tell me. 2, 8,
8 over 1.
8, 1.
19.
Again, what? 2, 8, 9. Is there anything else?
19.
What? Total 19. Okay, so this one if I draw, first shell 2, second shell 8, third shell again 8, fourth shell 1. This one if you draw, first shell 2, second shell 8, third shell 9, which is correct? Only one is correct.
It's not, it was 19 in the first.
That is why I already gave you. You didn't understand this?
And
Ah, okay. Okay, which is correct? Why second is wrong?
because maximum number of electrons in one shell is 8. To the valence shell. No need to use the word.
M shell can hold 18.
Balance shell is.
Being an outermost shell,
Yeah.
the maximum number of electrons that can be held is 8 only. M shell maximum capacity is 18. But being an outermost shell, it can hold only 8. So once 8 electrons is filled in the outermost shell, then the electrons started getting added in the next shell. Okay, that's why. Okay, after that, this outermost shell will become 8, and then the M shell starts adding 9, 10, 11 like that. That is how it works. Okay. Now, what's the homologous series? What do you mean by homologous series? So heteroatom functional group homologous series, 3 important definitions. What's a homologous series? Homologous series, same functional group. Yeah. What is homologous series? A series of compounds in which same functional group substitutes for hydrogen. These terms are very, very important. Okay, all these 3 definitions you should study properly, not in your own words. Heteroatom functional group and homologous series. See, the compounds, a series of compounds. They are in the textbook. Below homologous series, the last sentence in the first paragraph. A series of compounds in which same functional group substitutes for hydrogen in a carbon chain is called homologous series. Okay. Now, homologous series, you should add more points. 2 consecutive members of homologous series differ by CH2 unit. CH2 unit. They differ by CH2 unit. And their mass differ by for example, CH4, C2, H6, C3, H8. The 2 consecutive members differ by CH2. CH2. And what about the mass? 12 plus 2, 14. Their mass, consecutive members, the mass differ by 14. Okay. And there are properties. They will show similar chemical properties. But what about the physical properties? As you go higher in a homologous series, there is a gradation in the physical property. Okay, that means the melting point increases, the boiling point increases because the molecular mass as it is increasing. So as you go higher in a homologous series, the physical properties like boiling point, melting point, all increases. Okay. Now write the question. Write the next higher order homologues of, write the next higher order homologues of, write the next higher order homologues of First question CH2O. Second question C2H2. Third question C2H5COOH. Write the next higher order homologue of these three. What? So if they're simply asking you this question, you have to add CH2 to the previous one. Just add CH2. Here one hydrogen will be added. So C2. One carbon will be added and two hydrogen. It will be H4O. That is the next homologue. There is a difference of CH2. That is what we discussed, right? So two consecutive members, there will be a difference of CH2. So just add CH2 to this member, you will get the next. So here it will be C3H4 will be the next homologue. Here it will be C3H7COOH. So don't make any change in the functional group. Functional group will remain the same. Okay. Got it, right? All of you got? Now write the question. Name. Name. Yeah. Name. Name the compounds. Yeah. Draw the structure and name the compounds. Named. I want you to name the question, okay, not the answer. 1, 2, 3, you named it. Draw the structure of 1, 2, 3 and name that.
Question. Question or answer?
Question. Okay. What's the name of the first one? Hmm? What?
Methoxy.
What's the name for the first one?
I'm ignoring it.
What's the answer for the first one? So there should be double bond, right? Then only the valency will be satisfied. What is this? C double bond OH. What is that? Aldehyde. Methanol. Oxide is not double bond. Okay. Understood this. Okay. So this is C double bond OH. So that is CHO. That is an aldehyde. Methanol. The name will be methanol. Correct. You have to draw the structure, then only you will be able to identify the name. Okay. And what about the second one? Ethene. Ethene. No, ethyne. Ethyne. CnH2 and -2, right? And this is what? Ethanoic acid. Sorry, propanoic acid. 3 carbon. Propanoic acid. This is 3 carbon, okay? Propanoic acid it is. It is having 3 carbon. Amrita, 3 carbon is there, 2 and 3. That's why if you draw structure, you won't go wrong. When you see, I also after checking immediately see to okay, ethanoic acid. No, you have to draw structure, then you won't go wrong. So propanoic acid. This one is what I'm saying. Okay, clear, right, all of you? Clear. Is it okay? No, right. Draw the possible isomers of draw the possible isomers of compound with molecular formula draw the possible isomers of compound with molecular formula C3H6O
Can you repeat?
C3H6O and also give their electron dot structures. And also give their electron dot structures. Do. Finished? Finished? So the question was C3H6O. Three carbon. Six hydrogen. So it can be an alcohol. Okay. And this OH can be anywhere. It can be in the last carbon or in the second carbon. Two possibilities. But this is wrong, right?
So,
This is correct, right? 1, 2, 3. First, I will check for ketone. 1, 2, 3, 4, 5, 6. This is correct. 6 hydrogen. Ketone is okay. Ketone will work. Now, ketone can be in the double bond can be in the middle carbon only, so it will work. Okay. Now, if I check for alcohol, 1, 2, 3, 4, 5. More hydrogen is required, so it is not alcohol.
we'll try aldehyde.
We'll try aldehyde. Aldehyde is okay. Okay, aldehyde can be in the last carbon only. So aldehyde is okay. Is there any other possibilities? Ketone, aldehyde, carboxylic acid, no. Only those two. Alcohol is not possible. So these are the two structures. Now will you name this? This is
Propanoid.
propanol. This will be propanol. You have to draw and check. Understood? Okay. The one oxygen means it can be an alcohol also, but here the number of hydrogen is not enough for being a alcohol. Number of hydrogen is less, so double bond is required. Draw and name all isomers of hexane, A. Draw and name all isomers of hexane. Draw and name all isomers of hexane. They were asking electron dot structure also, that you'll be able to do, right? Anybody is having doubt means I will show. You are down. Electron dot structure. Okay. This one. Then I will draw the electron dot structure as well. So 3 carbons. Here this first carbon is sharing 4 electrons on all 4 sides. This carbon sharing 2 on either side. And 2 is on the lower side. So okay. And this carbon on all sides. Now hydrogen, 3 sides. Here oxygen. Now hydrogen. This is how it is. Okay. Understood. Understood. Now this one. No, you understood, no? So this one, 2, 3 carbon. So on 4 sides, this one also 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. And for this carbon, 2 on one side. The hydrogen. This is how you will draw the electron dot structure. Okay. Finished, right? Write the question. Explain the given reaction with examples. Explain the given reactions with examples. Explain the given reactions with example. What's the question? First, hydrogenation. What, Ryan? Yeah. Explain the given reaction with example. Hydrogenation. Do. What is hydrogenation? Adding of oxygen is hydrogenation. Huh? Adding of hydrogen is hydrogenation. Enough. For 2 marks, that is enough. You need only you need only 1/4 marks. Okay, then half mark. The addition of when hydrogen is added to an unsaturated hydrocarbon having a double bond, triple bond in the presence of nickel catalyst. That is hydrogenation.
What's it being taken?
Okay, right. When hydrogen is added, right. When hydrogen is added to unsaturated hydrocarbon, this is coming in under addition reaction. That vegetable oil, animal fat, there it is coming. When hydrogen is added to unsaturated hydrocarbon, having double or triple bond, when hydrogen is added to unsaturated hydrocarbon, having double or triple bond, in the presence of nickel catalyst, in the presence of nickel catalyst, it's called as hydrogenation. Okay, write the equation as well. Write the equation. You write ethene plus hydrogen in the presence of nickel catalyst 573 Kelvin is also mentioned in the textbook. Is the temperature mentioned? If temperature is mentioned, you must add that also. Check the textbook addition reaction. Is temperature mentioned or not? No? Above the arrow not mentioned? And then no need. Plus hydrogen you can put. It will become this is what is happening, right? This is hydrogenation. Addition of hydrogen to an unsaturated hydrocarbon in the presence of nickel catalyst. Nickel, okay, not hydrogen. Sorry. In the presence of nickel catalyst.
Nickel or palladium.
Yeah. Okay. Second question. Hydrogenation is finished. Second one.
Ma'am, is that CH3 plus H2 or CH2 plus H2?
What you are asking, Alvin? I don't understand.
I mean the equation, right? Is it CH2 plus H2?
This is ethene. Ethene plus hydrogen.
Okay, ma'am.
C2H4 is ethene.
Okay, ma'am.
C2H4 you can write it as CH2 double bond CH2. Now oxidation. Second one, oxidation. The oxidation done. So oxidation? Reactions in which oxygen is added or hydrogen is removed is called oxidation. Write the equation, that KMNO4 equation. Write that, it is there in the textbook. Yeah, from the textbook you write oxidation equation. Okay. Did you write the equation? So CH, so it is actually methanol is converted to methanoic acid. Alcohol is converted to carboxylic acid. Addition of oxygen, right? It is oxygen is added and hydrogen is removed. That is known as oxidation. Here, in case of alcohol, on adding oxygen, it is converted to carboxylic acid. Now next, substitution reaction. You should write the definition and equation, okay? Substitution reaction.
What is the definition of oxidation?
Addition of oxygen or removal of hydrogen is oxidation. Substitution reaction. Yes. What is substitution reaction? The reaction in it's a reaction in which one or more atoms of a compound is replaced by another atom. One or more atoms of a compound is replaced by another atom. Did you write? Definition, yeah. The reaction is a reaction in which one or more atoms of a compound is replaced by another atom or group of atoms. Write the equation in the textbook. CH4 plus Cl2 gives CH3Cl plus HCl. What happened? Substitution is done? Done? No, saponification. Substitution you done? Equation also. Saponification. Stupid marks. They won't give. Saponification. What is saponification? What is saponification? Formation of ester is saponification. When ester react with sodium hydroxide, it produces sodium salt of the alcohol. Sodium salt of carboxylic acid plus the alcohol, right? Yeah. Say, Ryan, what is saponification? Okay. Right. When an ester react with saponification definition, when an ester reacts with sodium hydroxide, when an ester reacts with sodium hydroxide, when an ester reacts with sodium hydroxide to form sodium salt of carboxylic acid, to form sodium salt of carboxylic acid, to form sodium salt of carboxylic acid and alcohol, it is called saponification. This is called saponification. Done, right? Okay. Example you write from the textbook. The equation given in the textbook. CH3CO.
Plus
No. Left. This left side. What is it? CH3CO.
CH2H5.
CH3CO C2H5. Correct. Correct. Is it correct? What? This
when it reacts with that's the reaction to CH3COOH plus NaOH gives CH3COO and therefore it's
What? I don't understand what you're saying. What you're reading, I'm asking the
Okay.
equation in the textbook only.
CS3 C2H5 plus NaOH
Ah.
gives C2H5OH.
So when it reacts with this is in the textbook, right? When this ester reacts with NaOH, you will get sodium salt of carboxylic acid CH3COONa plus C2H5OH. The corresponding as alcohol.
Hydroxide is given on the arrow.
You can put it in the arrow also. Okay, this is okay, right? Now, what is the name of this ester?
Yeah.
Ethyl ethanoate. Ethyl ethanoate. You know how ethyl ethanoate is formed, right? Okay. Now write the question. You know, right? Explain the formation of. Explain the formation of. Methyl propanoate.
What is CH3CO?
See, sodium salt of carboxylic acid.
Yeah, but then like what?
That's it.
The form, like name.
That's it. Explain the formation of methyl propanoate. With equation, okay. Ethyl ethanoate, you know. Similarly, you do trimethyl propanoate. Ethyl ethanoate, you know how the ester is formed. It is there in the textbook. Refer that equation and write. I want all of you to write. I'm not going to write. Without seeing your answer. You know how ethyl ethanoate is formed. Yes, how the ester is formed in the textbook, you know.
And what is the formula of methyl propanoate?
That you have to form. When an alcohol and carboxylic acid form, I explained already how it is formed. If you don't know, you first do formation of ethyl ethanoate from the textbook. Then you do this. I want all of you to do and send me the answer.
And what is methyl?
Yes.
What is methyl?
One carbon.
Like methane means CH4, meaning like single bond, but like what is methyl?
CH3.
CH3. So methyl means C2H5.
Yes. Methyl propanoate. Okay. So what we already know is ethyl ethanoid. I'll just explain. Ethyl ethanoid, I'll explain. CH3 COOH plus C2H5OH. When they react, the hydrogen from the carboxylic acid will be removed and OH from the alcohol will be removed and the C2H5 will be attached to this. CH3 COO C2H5. It will be attached to this. This is how it is formed. Okay. So this is ethyl. Okay, and this is ethanoic acid. From there, ethanoate, ethyl ethanoate. That is how the name came. Okay, ethyl part from the alcohol and ethanoate is from the ethanoic acid. That is how the name came. Now, similarly, you try methyl propanoate. So, the alcohol should be methanoic acid. Then only you will get methyl. Okay, and the alcohol should be propanol.
Alcohol should be methanol.
Sorry, alcohol should be methanol. Then only you will get methyl, and the acid should be propanoic acid. Did you do?
Alcohol, propanol,
Propyl methanoate. What? Propyl. Finish this.
What's the difference?
What?
Between propyl methanoate and methyl propanoate?
Both are different. Both the formation is different.
Just formation or like.
No, all the formula, everything is different. You try the other one also. So ethyl part, this part gives the alcohol and ethanoid part gives the oic acid, carboxylic acid. So here also, this will be OH part and this will be COOH part. So the alcohol corresponds to methyl. It is methanol. So methanol plus propanoic acid gives you this. Understood? That is how you can identify. So you will get propanoic acid plus methanol gives you methyl propanoid. First you understand that. That is okay. Ethyl part will be from the alcohol and methyl part will be from the alcohol and propanoid will be from propanoic acid. Methanoid will be from methanoic acid, whatever it is. Now propanoic acid, you know, CH3, CH2, COOH plus methanol is HCHO. Correct? No. CH3OH, right? Methanol is CH3OH? Yes or no?
Yeah.
Correct, right?
Yes.
Methanol is CH3OH. So you will get the same. Remove hydrogen from this part and OH from this and attach this to this. CH3, CH2, COO, CH3. That is methyl propanoid. Understood, all of you? You should understand. Don't simply copy. You should understand this. Clear, right?
Can you do the other one, like methanoic acid and propanol?
You do. I'll check.
I do.
This one will do. Yeah, I know. Where is the section? In the equation, there is H2SO4 also. Okay, I missed that. In the esterification equation, there is H2SO4, right? That is there. In all equations should be there. Finished, right? That is okay. So acidification is okay. Now, we were doing saponification. Now next, the fifth one. Okay, we did hydrogenation, substitution, saponification. Now oxidation is the next combustion. Combustion reaction. Yes, there. Combustion reaction. Define, you should write the definition for combustion and you should write the formula also. That's finished. Read the definition.
When carbon is burnt in the presence of oxygen, they give out carbon dioxide.
Yeah, when carbon. When hydrocarbon is burned in the presence of air to form carbon dioxide, only carbon dioxide and water. Carbon dioxide and water along with heat and light. Burning of hydrocarbon, burning of, you can write burning of organic compound in the presence of air to form carbon dioxide and water. Just write any equation in the textbook, okay. Finished, right? Okay. Fine. An organic compound, an organic compound A, an organic compound A. I asked you to draw the isomers of hexane in between, right? All of you draw. We didn't discuss the answers. You didn't draw. Okay, after this we will do that. An organic compound A on heating with an organic compound A on heating with concentrated H2SO4 forms a compound B forms a compound B which on addition of hydrogen which on addition of hydrogen which on addition of hydrogen in the presence of nickel which on addition of hydrogen in the presence of nickel forms a compound C. C on combustion form. C on combustion form. C on combustion form. Carbon dioxide and water. C on combustion form, carbon dioxide and water. Identify ABC and write the chemical reactions involved.
What's after the presence of nickel?
In the presence of nickel, form compound C.
Wait, I need the ABCN.
Write the chemical equations involved.
So
No. Which equation they are referring to?
Alcohol plus removal of water. So
Dehydration reaction. Heating in the presence of H2SO4 is dehydration reaction. That is the only reaction in which heating in the presence of H2SO4 is mentioned. That's the last property of ethanol. Ethanol, chemical property, the last one. So the chemical compound will be ethanol. Ethanol on heating in the presence of concentrated H2SO4, you will get ethene, which is unsaturated. Ethene in the presence of nickel catalyst, you will get addition, that is addition reaction. You will get ethane. That ethane, burning of ethane, saturated hydrocarbon. It produces carbon dioxide and water. That is the three equations. So here, what all things are happening here? Dehydration is happening. Then in the second step, it is addition reaction. And in the third equation, it is combustion. So they can ask you to identify the reaction also. Identify the compounds and chemical equation is only they asked. They can ask identify the compound, the reactions. So three main reactions are happening here. The reactions, and they can ask you to write the chemical equation, right? So first of all, compound A on heating with H2SO4. So the compound A is ethanol. So C2H5 OH on heating with H2SO4. You will get CH2 double bond CH2 in the presence of water. This reaction is dehydration reaction. Now this is B. Now B is CH2 double bond CH2. They're asking in the presence, what they're asking? On addition of hydrogen, right? On addition of hydrogen in the presence of nickel catalyst. I mentioned that addition of hydrogen, right?
Yeah.
Okay. So CH2 double bond CH2 in the presence of nickel catalyst, addition of hydrogen, you will get CH3 single bond CH3. So this reaction is addition reaction. Then C2H6, that is C. Then C2H6 plus O2 heating, right? You will get CO2 plus H2O. And this is oxidation, no, combustion. These are the three equations and compounds. Okay, understood. All of you did isomers of hexane? How many isomers you got? 2. For hexane, only 2 isomers. Oh. You got time only for doing 2. Okay, complete that. Isomers of hexane. Yes. It's a board exam question. Previous year question. Draw and name the isomers of hexane. No, okay. I have to finish the one. Okay, what the answer, all of you? Hexane, right? Hexane. Okay. You have to name it also. Okay. So, first to hexane means first of all, what's the formula? C H14. 1, 2, 3, 4, 5, 6. Hydrogen is there, I'm not putting. It's fine, right? You know. This is known as which, what's the name of this?
And
N-butane, normal butane. You call it as N-butane or normal butane. Then 1, 2, 3, 4, 5. Sorry, hexane, correct. What about this? So this will be CH3. So what is this? 2 in the second carbon. 1, 2, 3, 4, 5. The second carbon, which branch is there? Methyl. 2 methyl. The longest chain is with 5 carbons, so pentane. 2 methyl pentate. Understood? Now 1, 2, 3, 4, 5, 6. Where is the branch? Third carbon is the branch. So this will be 3 methyl. The branch is methyl pentane. Is it okay? Now CH3 can I put here? No, doesn't make any difference. Because if I put CH3 here, that is also will be the second carbon from right. If I put CH3 here, that CH3 will be on the second carbon from right. You will name the carbon such that the carbon with branch will get the least number. We numbered like this because it was on, branch was on the second carbon here. If the branch was here, I will name like this. That also will be 2-methyl pentane. Okay, now. What is next? Is there anything else with pentane? No. 1, 2, 3, 4. What? 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 Did you say something? Okay, this is okay? Correct. What is the name? So this is again with the 6 carbons. What is the name? In the second carbon is the branch. How many branches are there? 2 branches are there. 2, 2 dimethyl, because 2 in the second carbon 2 branches are there, both are methyl. So 2 dimethyl butane. Then 1, 2, 3, 4. C2H5 I can put, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You have to check, okay, whether hydrogen number is satisfied or not. So this also in the second carbon, 1, 2, 3, 4. In the second carbon, ethyl is the branch. So 2 ethyl butane. These are the 5 isomers possible. Is there anything else possible?
3 dimethyl.
1, 2, 3. Okay, now next is 1, 2, 3, 4, 5, CH3 here, CH3 here. This is also possible. That is what? In the second carbon and third carbon branch is coming. What is the branch? 2, 3 dimethyl. Dimethyl. What is that? Butane. 2, 3 dimethyl butane. Got it, right?
What about propane? Liquid propane.
Check. If propane is coming, no, not possible because 1, 2, 3. Then how many more carbons are there? 3 more. 1, that 3, then this become again butane chain. If you place like this, it will become a butane chain.
What if you put CH3 down and
From the middle.
Oh, that is what I did. What?
Put each down and methyl or so.
I don't understand. Tell me. How many carbon?
3 carbon
1, 2, 3. Okay.
down methyl,
CH3 then
up methyl.
C2H5.
Yeah.
2, 3, 4. That will be the long chain.
Yeah.
4 will be the long chain. Understood? Okay. Okay. So revise all of you this chapter. Okay. And you should practice, then only you will get doubts. This chapter is not hard if you understand. If you are still not getting, you tell me. Okay. Okay then. You should study, okay. Now you have to study. I'll put your carbon test later. Those who attended today, I'll put a carbon test later. Okay. Okay, then.